Okay, so like I was just mentioning, today we are starting, we've learned a little bit about causal loop diagrams. I know we went a little bit fast in the last lecture about exactly what words you should use in the causal loop diagrams and so on. Don't worry, we'll come back to that and you'll see it again in the chapter that you'll be reading, I think, for next lecture. I think a lot of people have already started reading that. There's some great comments on perusal. I appreciate everybody's engagement there. So today, in the middle of all that, we are now going to introduce Vensim as our first tool to help us draw these causal loop diagram descriptions for these systems. So Vensim is freely available, and there's information on Canvas. If you go to the course information down, I think it's kind of in the middle to the bottom of that, there is a page on Vensim about where you can download Vensim and get other resources for it. It's also here in the lecture slides. So if you are if you're in the classroom, then Vensim was supposed to be installed on all of those machines. It was confirmed it was installed a couple weeks ago for me. Otherwise, if you have your own machines, you can go ahead and download Vensim. You can either do it now as we're on this lecture. If your Zoom is in full screen, if you hit escape, it'll go out of full screen and then you'll get full control of your computer. And then you can download Vensim. You go to this website that's up here, and it shows you a page that's like this. You fill out whether you're Windows or Mac. I recommend turning off this subscribe link so that they don't spam you. And then you'll get an email link that tells you how to download Vensim. And then you can download that. And that will allow you to then install the program. And so other resources are also linked in the syllabus as well as other places on Canvas. And so, for example, Craig Kirkwood is a business faculty who just happens to be an ASU business faculty who had produced a lot of resources on Vensim kind of earlier in his career that are archived on his website. And so I put one of them here. Again, these are a little bit older resources. And so the diagrams that he has in those resources are from an older version of Vensim. So they don't completely match up to the version that you see, but pretty much all the same components that are in your version or in his version, just maybe with a slightly different icon or a slightly different placement. So if you're looking for other resources about Vensim, I highly recommend taking a look at that. Okay, so again, you can feel free to try to download Vensim right now as we're talking, or you can wait on that and we'll have some time to do that later. So when you open up, so what's Vensim? So Vensim is a program that is built for system dynamics modeling primarily. And so it allows you to do two things. It basically allows you to draw causal loop diagrams, and then it allows you to draw stock and flow diagrams and simulate them to generate these behavior through time or behavior over time curves that we've been starting to talk about and you've been starting to see in your book. And so we are going to focus on just the causal loop diagrams today. I've mentioned there's another tool that we use called Insight Maker that is a web-based tool. Insight Maker, which is sort of designed to mimic Stella, which is the tool that your book uses. Insight Maker is great for stock and flow diagrams, but it isn't quite as nice for drawing these causal loop diagrams, which is why we kind of focus on Vensim. Now, causal loop diagrams, as you've seen, they're not that complicated, right? They're just text and arrows. And so if you don't like drawing your causal loop diagrams in this class in Vensim, I'm happy if you want to say do it in PowerPoint. You can draw great causal loop diagrams in PowerPoint. You just put some text somewhere, you draw an arc with the right arrow, and it's fine to do. What's nice about Vensim is it automatically knows that all of your arrows are probably going to need to be curved and they're probably going to need to be labeled with a plus or a minus. And so it already has all this stuff built in that if you wanted to draw them in PowerPoint, you'd have to do a lot of manual work to get like all of the right annotations there. But if you're okay with that, then I'm fine with you using another tool. So you don't have to use Vensim to draw your CLDs, but you do need to have good looking CLDs that are easy to read. Now, if you do use Vensim, which I recommend you do, then we'll go through kind of a tutorial of how to use Vensim to draw these CLDs. And so I've got Vensim up on my end, and so I will then kind of be going back and forth between the presentation and my version of Vensim here. So what you've seen that I've dragged in front of the presentation is my Vensim. And so you can see it looks just like the image that was in the presentation behind it here. And so I will try to run in some live demos, but just to show you that these instructions are embedded inside this presentation, which is available online, I'll also kind of go back and forth between the presentation here. So as the presentation shows, when we open Vensim, we focus primarily on these three buttons up here at the top. There's a button in the toolbar called variable, and there's a button in the toolbar called arrow, and the button in the toolbar called comment. And so the variable, those are the things that our causal links are drawn between. The arrow, that's what we use to draw our causal links between things. So like we'll see in a second, hunger and amount eaten. So you can do a hunger and amount eaten, those will be variables. And then the fact that you know, if you're hungry, that's going to increase the amount eaten, that's a causal link, and then you'll draw that. Once you end up identifying loops, then you'll want to do those loop annotations. So you'll want to be able to say this loop is a positive feedback loop, and maybe you want to add a little bit of text and say this is my hunger control loop or something like that. And that's all loaded up here in these comments. Now, those are the three main things you use, but then occasionally you're just going to need to do some editing. And so there's this move size hand here that when you click on that, you can drag elements and move them around. When you click on the delete, then the next thing you click on goes away. And so those are the ways that you mainly are going to work on this canvas. So there's a lot of other stuff here. We're going to get into that other stuff when we start drawing stock and flow diagrams. But for now, you could ignore all that, like IO object, equation, shadow variable, rate. Just ignore all of that. Be careful because rate looks like an arrow, but we aren't going to use rate until we get to stock and flow diagrams. So the arrows we use are these arrows, these thin arrows right here. So how does it work? So you go into Vensim, and if I were to click on variable, then I can click anywhere and start typing a name. So if I go back to my Vensim here, then if I go up here and click on variable, and then I just click anywhere, so just left click anywhere here, then I can type in a variable name, hunger. If I, you know, let's say that, and this is it's going to get a little advanced, if I were to go to my move size and right click anywhere on the canvas, then it's going to bring up this defaults view here. And I am going to make my default font bigger. So I think I'll make it, you know, 36 point. Let's see how that looks. So now it's a little bit more readable, I hope, for you guys. So I'm going to go back here to my variable, and I'm going to click elsewhere here, and I'm going to type amount eaten. And then I've got my two variables here. And if I wanted to, I can click on this move size and I can move them around. All right, pretty easy stuff so far. If I'm trying to think if there's anything else I want to mention here. All right, yeah, that's pretty much it. So any questions on that? Pretty simple so far. We haven't drawn the links yet. That's in the next step. Okay. All right, so in a causal loop diagram, you've identified all of the things that you think could be playing a role in the kind of causal description of what's happening in the system. In this case, our system is kind of the hunger control system. And so we think that all we really need to worry about is hunger and amount eaten. So now we can move on to drawing our causal links. So I'm going to go and I'll tab back to the PowerPoint here. And I can then focus now on the arrow tool up here. And when I click on the arrow tool, which I'll show you in a second, I will then be able to click on one of these, which is kind of the source of the arrow. And then it will then have this kind of dangling arrow out here. And then I can click on the sync. And at that point, it's going to draw a straight blue line that is going to represent a causal link between these two. And I'm going to want to make that look curved, because as we'll find out when we read the chapter, it's just conventional that links that participate in feedback loops are curved so that you end up getting these nice kind of oval shaped feedback loops. And so there is a little circle which will be right in the middle of that link, that if I grab that, and I saw the question here in a second, if I grab that circle and drag it up, then that allows me to add some curvature to the link. So there's a question and said, can I go back and show how I renamed a variable? So I didn't show that, but I definitely can show that. And so if I go back to that slide here, I think I mentioned that if I want to rename a variable, I can use the hold tool. And so let me show you how I do that. Thank you for asking that question. So let's say I don't like the amount eaten. If I go to the hold, or if I go to the arrow tool here, let's make sure that I do this right. Oh, I'm sorry, I didn't mean to say arrow. If I go to the variable tool, so if I'm in the variable tool, if I click somewhere else, I can create a new variable. Now I didn't want to create that new variable, so I'm going to click on delete and delete that variable. Now, if I'm in that variable tool and I click on an existing variable, then it allows me to rename the variable. So I can say, instead of amount eaten, I could say quantity eaten or something. And then I look at that and I say, well, I don't actually like that term. So I'm going to click on it again, and then I can say amount eaten. So now it's back to that. Now, you notice there's a little handle here, this little circle. I'm going to call those handles. And so those things there allow me to resize this box here. So there's no box that's being rendered here, but you can see that as I drag this thing around, it wrapped that amount eaten. And if I drag this thing wider, then it unwraps that. And so if you're having trouble with your text being like super wrapped or something like that, then you can grab that arrow, that little handle, that little circle that's kind of at the edge of an invisible box, and drag that box around. All right. So links, let's show how we do the links. And so I'm going to go back to this slide, and I'll go back to the Vensim here. And if I click on the arrow tool, I can click on amount eaten, and then it's got this dangling arrow. And so I'm going to click on hunger, and it'll connect the two of them together. And by default, it just chose blue. And the reason it chose blue, as we'll see in a second, is because I've got that set as my default color. Now notice that this has a little circle in between it here. That's another, again, one of these handles that allow you to grab that. If I grab that handle, I can drag it up and I get a nice arc. So there we go. All right, any questions about drawing the links there? You just click on the source, you click on the sync. If you happen to get something wrong, you can click delete, go back, and it's hard to figure out where to click delete here. You delete from the head. You find the little arrowhead, and you should be able to click there, and eventually you'll get it. I just picked the head because it's like a large piece of real estate. It's kind of hard to find it otherwise. And then I can go back and I can re-add that link. So I'll click, oh, I hit the wrong button, hit arrow, hit hunger, and then drag that thing up to make a nice arc. And looking ahead, I could then draw another link. So I can say, well, there's also a feedback path, a causal path from hunger back to amount eaten. So I'm going to click on hunger, and I'm going to go to amount eaten, and then that will draw, that'll complete that path. And now I can make a nice oval out of this. All right. Any questions about that? Drawing links. All right. So I'm not going to pause as long as usual when I ask for questions here, but anticipating that as we go on, some questions will get answered as I start working through things, and then other questions will be generated. And just holler if you want me to stop and go back or show you.
I have a question.
Yep.
For some reason, when I click on the arrow to create an arrow, it like keeps going with the arrow, and it's not letting me like stop at like hunger.
Okay, so sometimes it's just a little tricky in figuring out that there's a variable there. Vensim's a little hokey. If I were to delete this arrow here and try this again, if I happen to click somewhere else, it then will create this kind of angle here. So if you see it creating a bend, then it's registered you've clicked, but it doesn't think you've clicked on something. So that means that you like need to try to click closer, and then it'll create it. If it's not creating it at all, then I think if I hit escape, yeah, I just hit escape there, and it'll stop that, and you might just try trying it again. You might try deleting your variable and re-adding your variable. So without seeing it, and later on, what we're going to do is we'll have an opportunity for you guys to break out into groups and work with Vensim, and I can go around and you can share your screen with me, and I can help you troubleshoot if it's still not working.
Okay, thanks.
All right, any other questions? Vensim takes a little bit of muscle memory to get used to, but eventually you get used to kind of its little idiosyncrasies of exactly where you've got to click things to get it to know what you want. All right, so next step here. Well, now that we've gotten these arrows, we want to make the arrows look like positive arrows and negative arrows. We want to add delays, all of that sort of stuff. So how do we do that? Well, so as I'm documenting here, and as I'll show you here in a second, if you are in the arrow tool, if you right click on that little handle, it will bring up an options box that allows you to set all sorts of options about that arrow, whether it's got a little polarity annotation on it, whether you want to use plus minus or SO. Remember, S is same and O is opposite. S is like a synonym for plus and O is like a synonym for minus. You can change the font of those things. You can decide whether you want the polarity above or below. You can just say, do you want a delay mark on there? Remember, delays are important, especially in this hunger loop. So let's go and try that with this loop here. So I'm going to go back to my Vensim, and I'm in the arrow tool up here, and I got the handle here. So I'm going to right click on that, and it opens an options box for me. And it put that on the other screen for me, but for you, it should pop up, right in front on top here. And I am going to say, well, after I eat something, my hunger doesn't immediately go away. It takes time. And so I'm going to turn on this delay mark. And then if I think it through, when I eat something, eventually my hunger goes away. So that's a negative causal link between amount eaten and hunger. So I am going to select this as a negative arrow. And what I might do is I might click on font here, and I would say that I want to make sure that this negative is big enough. And so by default, it's 36 point. I have a feeling that's going to be big enough. Might even be too big. So I might try a different font size and just see how it ends up looking. But I am focusing here on color. Now, I'm not going to take off any points if you don't color your diagrams. There's a question, how did I open the options again? Right click on the little handle, the little link. So just take your mouse and on the little circle that's right in the middle of that link, right click on it and it should pop up the options. So I'm not going to take off points if you don't color your diagrams. You can leave all the arrows blue, but it's easier to read if you add some color to them. And a conventional coloring is blue for positive, red for negative. And so I am going to make this color. So I'm going to go through, I'm going to click on this. I've lost my window here because I'm on two windows. I think Vensim, let me see if I can find it. Popped up the color window, just a second here. Sorry about this. I think when I went back away to Zoom, then yeah, the conventional coloring is blue for positive and red for negative. But as long as if they're two different colors and you're consistent, that's great. I don't really care if red is negative and blue is positive, just as long as it's easy to figure out which is which. If they're all black or all blue, that's fine too. The most important thing is that they're labeled so that if you were to print it out in black and white, it would still be readable. So that's kind of the important thing. All right, so okay, I think I managed to get it. All right, so I'm going to hit font selection. Let's try that again. I apologize for that. I think the color window, when I clicked on it, it shows up. I think Vensim is confused at my double monitor setup with Zoom and PowerPoint. Oh, there, okay, I found my colors. So they showed up in like a really funny position and now they are missing. So if I click on that again. All right, so I'm not going to be able to change my colors right now because I think I opened Vensim at an inopportune time. And so when you click on this color, you should see like a palette of colors pop up, like a big grid. When I'm clicking on colors, that palette like actually shows up in a weird spot. I think I managed to get it because I'm on 2 monitors. Like it actually put the palette on the other monitor, but it's like hidden behind PowerPoint. So I managed to get it. So now I should have a red arrow with a delay mark. I have a blue arrow with a delay mark. So let's see if I can fix that. Apologize for these technical snafus. So my polarity, the color of my line is here. And also the thing is there's 2 colors. There's the color of the line, which is up here. And then there's the color of the polarity, which is in the font window, which is here. And so I've managed to make both of them red here, the color of the polarity and the color of the line. So if I hit OK, then finally I get a red arrow with a little minus. And that minus sign is 20-point font. So it's a little smaller than these ones here, which I'm thinking might look a little bit better. All right, so now I need to go and do a similar thing for this link. And so with this link, if I think about it, hunger versus amount eaten, then the idea here is if my hunger goes up, then I'm probably going to eat more. And so, and that might be immediate. If I'm immediately hungry, immediately I'm going to want to eat something. And so that doesn't require a delay. So that sounds to me like a positive link. And so I'm going to put a plus here. Again, I might go into the font and I might be afraid that the 36 might be a little large. So maybe I'll make it 22. I'm going to leave the default color, which is blue. I'm not going to select the delay. And so then I end up getting this thing here. And I'm going to make that, I might make that font of that little link or that little plus. I'm actually going to make it blue just to be the same color as the line. So if I do that, I can select blue. And I also kind of like, maybe, you know, just for kicks, I'm going to show you, I'm going to do it. I'm going to say I'm putting it on the outside of the link. So I selected outside here. So now if I do that, then now I got this nice blue link down here with the plus on the outside. All right, that was exhausting for me. Hopefully it was not exhausting for you. Are there any questions about drawing these links and adding these annotations to the links? In the background, if you happen to hear a high-pitched release, my wife is making tea, and while she's doing it, she's running a training session for our puppy. You know, I have to do about 5 minutes of training per day. And so, so you're hearing him being released from a sit. So I don't know if you can hear that, but if you're wondering why there's somebody who keeps yelling release behind me, it's because we're training a puppy. All right, any other questions or anything?
I do have a question. If there's a way
Yep.
to set it so that this sign is always going to be this color without you having to do it manually one by one?
There are, so that like the link labels are always blue. I have to think
Like the
about
positive
that, but
one's always blue and the negative's always red.
yes. Unfortunately, Vensim is not quite that smart. So if but I'll show you in a second. There's a way to go through and highlight a bunch of different labels, and then say I want all of these labels that I just highlighted to be changed to red. So you don't have to go through this like multi-click process to change every one of them. You can do all that later. So so I'll show you that in a second, so you get an idea of how to do that. And yeah, the next time Dexter, my puppy, is up here, I'll be happy to show him to you. He might then proceed to chew on my legs for the rest of the lecture, so that's a liability. But yeah, the next time he's upstairs, I will show him off. All right, so so yeah, let's move ahead here. The last thing then that we need to figure out how to add is this annotation to the middle of the loop. And so, so that is done with this comment button that's up here. And when you click on this comment button, then you'll be able to click on the middle of the loop, and it will then open up this option that allows you to put a bunch of different things in the middle here, like a little diagram that is going to show that maybe it's a little negative feedback loop, or even an annotation that says like hunger control. So let's see what that looks like. So I'm going to click on the comment here and click in the middle. And that brought up a little comment box here. And I can then go down to, like, look down here on the bottom left, there's this thing called graphics. And so if I click on image, if I select down here, it's got a bunch of preloaded images. Now, this has got one negative in the loop. And so I know it's a negative feedback loop. So I want to find an image that I like for depicting a negative feedback loop. I'm kind of boring, and so I might just choose a minus, or a big negative. Now, I can go up to the appearance here, and then I can actually put things around that image. So I know that I've drawn this kind of anti-clockwise, counterclockwise. So I'm going to select loop counter. And then maybe just for style, I'll go under the color here, and I will select a red color for that annotation that's going to go around it. You don't have to do that. I think it's a lot of people just do their loop annotations in black, but I'm just doing it here to show you can do it. And I could put a comment here as well. I could say hunger control, but we might see that I might just want to create a separate annotation for that so that I can control their position independently. But let's see how that looks. I definitely think the font being 36 is going to be probably too big for this. I'm going to try 18 and see how that looks. And then for text position, I'm going to try above and see how that looks. So I've done all that. Let's see what comes out of that. That doesn't look that bad. So I can go to move and move this around. And I can hit this little handle here. And I can make that little negative feedback counterclockwise thing a little bit bigger and a little bit smaller, and it puts hunger control on top of that. And I wasn't quite sure if I would like how that looked, but it's not that bad, so I might just leave it just like that. But if I wanted to, I could create a second annotation that just was text, that didn't happen to have an image. It would just have image none, it would have no loop, and then I could have a hunger control that would be like independent from this loop annotation. And then that's most of our loop there. So are there questions there about drawing that annotation? Okay. All right, so this is just what everything I just did with you, I'm just kind of stepping through here in the slides. So this is just a reminder where all those things are. In the slides, I used a little teeter-totter or seesaw, and that is another common image to represent negative feedback loops. So that is another option that you can do. So I get a similar loop on the screen as I did in Vensim. Any questions about any of that? Does that all make sense? All right. So now, go ahead. Yep, go ahead.
How did you do those double parallel lines on top of the negative loop again?
Gotcha. The little delay indicator, and I think by the way, for background, I think the reason why double lines became the delay indicator in system dynamics modeling is that some of the original system dynamics modelers were actually electrical engineers. And electrical engineers grew up knowing that you implement delay with something called a capacitor. And the electrical circuit diagram element for a capacitor are two little parallel lines. So that's where that's coming from. It's like it's a capacitor slows down things, it adds delay, and that's why that's there. The way where we get to that, and that's an excellent question, I'm glad you asked that. If you are in the arrow tool, if you right click on the handle for a line, then there at the very top of the resulting options window, there is a little checkbox that says delay mark, and you can turn that on and off. If I turn it off, it'll get rid of those double bars. If I turn it on, it'll turn them back in. Turn them back on.
Wait,
any other question?
Where did you click that again? I'm sorry. I was trying to look at
no problem. No problem. It's right up here. Can you see that on my screen? It's
yeah, I see that. How
mark.
did you get to that again?
All I do is I right click on the little handle. So if if you look, there's a little handle in the middle of this line. If you go to the arrow tool up here, so if I click on the arrow tool, I accidentally hit right click. If I right click on that circle, that should open for you an options box that looks like this.
Okay, thanks.
And then yep. Any other questions? Some of you have probably noticed that as you're using Vensim, for those of you that are following along at home, this keeps popping up. Do you want to save your sketch to enable automated backup? I keep hitting no to that every time it pops up just because I'm trying to get it out of the way. It's an excellent idea to do that because especially if you're a Mac user, the Vensim version on Mac, up until recently, would flake out all the time at random times. It wouldn't matter what you were doing, it would just be, it would crash. And then you would lose your work if you didn't have that thing automatically saved. So I definitely recommend you do that. Vensim has told me that they think they fixed that since the last time I taught this class. But we shall see. So it's a good idea to hit yes for that. But for this little demo, you don't have to worry about it. So I'm going to hit no. But if you don't hit yes, it'll just keep popping that thing up every, I don't know, 30 seconds or a minute or something like that. All right. Yeah, so there's a comment in the chat. I have a Mac and have some error messages already while clicking. Yeah, so it's a little flaky on Mac, but it is a platform that is well known in the industry. It's used in the industry. It's something you could put on your CV that you've used Vensim, and it has multiple platform support. So it's a little, and the other thing is it's the educational version. The professional version is much nicer, and they've ironed out some of these details. I think they kind of use some sort of deprecated code base for the educational version, the free version. And so it's a little frustrating, but you get used to it. All right. So the next thing is you draw this nice diagram. And so how do you export this diagram for reports? Now, I know you guys are experts at screen capping, I think as people say, screen capturing, which is one way to do it. But if you want a nice vectorized version, so what I mean like that is you want to make the diagram so if you bring it into a PowerPoint in your term presentations, you can drag it up and down and at any size it looks good. Or in your Word doc, you can drag it around and make it any size and it still looks good. Then it's better to use the copy and paste that's native to Vensim. And so what you basically do is go into Vensim and you can go up to the edit menu, or actually, I'm sorry, the easiest thing to do, I think, is to click on the move size. And if you click somewhere else, you can draw a box. And it will then allow you to select multiple things in that box. And from there, you can either use the copy button that's up here, or you can go to edit and copy. And then if you then open up a Word doc and paste that in, or Google Docs or whatever, if you open up any of those apps and paste it in, it actually pastes in a vectorized version of the graphic. And all that means is a fancy way of saying that it's going to be crisp and clear regardless of how you scale it. And so I think my Word recently went through an update, and so it's not like opening. So I'm just going to force quit. And okay, so you may have to take my word for it, pun intended. Let me see if it starts up this time. All right, there it goes. Open up a blank document. So if I paste it in, I just did an Apple V or an edit paste. And then it pasted this in this vectorized format, which means that if I were to select this thing and drag it around, then as I drag it, you can see that I'm not getting any pixelated features. It's nice and sharp all the time. So that is the way that I recommend you copy and paste these diagrams for your reports. Now in Insight Maker, screen capping is really the cleanest way, or the easiest, the quickest way to do it. There are ways to export vectorized images from Insight Maker that we'll learn about, but it's a pain. And it requires you to export SVGs. And if you're not comfortable dealing with SVG files, then it ends up just not being worth it. But fortunately, they've got this nice vectorized feature here inside of Vensim. All right, so let's get a little more advanced. And so quick formatting, there are already some questions here. We're like, wow, this is really annoying to change the color of all of these things. There's a comment here in the chat, if my Mac is in dark mode instead of light mode, can you change the settings so it can be in light mode in only Vensim? That is a question that I can't answer off the top of my head. That might be something you could do. There certainly could probably download a third-party tool that automates the switching of light mode to dark mode. I'm pretty sure there's several of those tools that exist, but inside Mac natively, I don't know if there's a way to say, when I'm in Vensim, go to light mode, and when I'm in everything else, go to dark mode. So sorry about that, but I do think you can put a light mode, dark mode trigger in your taskbar at the top and then be able to switch back and forth pretty quickly. But your mileage may vary, so don't quote me on any of that. And if you do find an elegant solution, let me know. Okay, so for the quick formatting here, I just showed you can select things. So you can select multiple things at a time, and then so that's one thing. So sorry, I got ahead of myself. I showed you earlier, if you right-click on the blank canvas, you can change the default settings, the default arrow color, the default fill color, shape color, etc. And so this is a great way to say, all right, I'm sick of changing font size. I want my fonts to be 30 all the way throughout. Just change it here. Now you do that just by right-clicking anywhere on the canvas. I already showed you that. Just go into right-click here and it'll bring up a view defaults here. So that's one thing you can do. The other thing you can do, as I summarize on the next slide page here, I think, is notice that there's this little ribbon that runs across the bottom. This basically allows you to quickly set the features of whatever is currently selected. So you can select multiple things holding down your shift, for example, and then you can go down here and change their font size, their colors, the arrow type, etc. So let's see if I can give that a shot here. I go back to Vensim. I'm in my move size tool. I'm going to maybe hit on, you know, maybe I'll select this arrow and maybe I'll select, you know, this arrow as well. So I've held down shift and then I clicked on the two arrows and only selected those two arrows. And then I can go down to here and then down here in the ribbon, it's a little hard to see, but there it says like Times New Roman 22. If I click on that 22, let me change it to 36. And if you can see, the size of those two pluses and minus both popped up. I could go to both of them and I could change their color. So I get clicked on this little color palette here, and it then brings up a color palette. I'm just, to be different, I'm gonna make them all, they're both green. Or I just changed, I changed the color of the lines to both be green. It's just to show you that I can do that. Now I just undid that, and so on and so forth. So if you mouse over these things, like this one says set color on selected vars. This one next to it says set box color on selected vars, set surround shape on selected vars, and so on. So basically, this is a quick access to all of the things that you normally would have to drill down into in order to find. And so that's what I'm kind of summarizing right here. So that isn't, you know, it would be great if you could say every plus sign should be blue, but we can't do that in Vensim. But what we can do is draw all our plus signs at once, and then later go through and hold down shift, and then click on all of those arrows. And then once I've clicked on all my plus arrows, then change all their colors at once. All right, any questions about that? And for more help with that, I've created a little video on Canvas. If you go into this unit, which is unit B, and under this lecture, there is an auxiliary video there where I've got some extra help on how to use those tools, where I give you more examples. Okay, great. So question slide there. All right, so that is our basic intro to Vensim. So now we're gonna remind ourselves a little bit about causal loop diagrams, and then I'll give you the rest of the time to start on your assignment, which is basically drawing a couple of causal loop diagrams yourself in Vensim. Or if you don't like Vensim, you can do it in PowerPoint or whatever drawing tool you like that you can make this stuff work in. All right, there's a question. If you right-click on the screen in Vensim, it will bring up a view defaults window where you can change the background color in Vensim. That's right. Yeah, so I guess that was more of a comment. Yes, that's one of the things you can change in Vensim. So that's one of those defaults. So thanks for pointing that out. The defaults aren't just the default drawing things, but they're also the default like background for the canvas and stuff like that. So if you don't like the white background, you can you know, change the background color there too. So yeah, good. I see, great. So that was a question about dark mode. And so if you really don't like seeing that giant white, if you got dark mode, you got that white box right in the middle and it really just burns your eyes, you can change the background. So thank you for pointing that out. So for those of you using dark mode, maybe try changing your background in the view defaults to a darker background. All right. Okay, let's do a quick attendance exercise just to keep everybody awake. So I will put the link in the chat there, and of course you can also get out the QR code there. And I guess for this link, I will for this attendance exercise, maybe I'll ask something about Vensim, and maybe the question is, how do you change the defaults? You know, drawing styles, background, etc. In Vensim. So what is the quick way to change the defaults in Vensim? And as a hint, this is an interaction you have with the canvas. So what do you do with the canvas, the big white background or maybe black background that allows you to change the defaults for everything in Vensim? All right. So let's then get our heads back into causal loop diagrams. So this is a diagram that I picked out from the National Research Council. So this is a diagram that was explaining climate change and you know, the basic mechanisms underlying climate change. And they were trying to communicate in this diagram that climate change generates a vicious cycle. So it generates a positive feedback that has a negative outcome. And this is like a causal loop diagram, like it's supposed to communicate the same thing as a causal loop diagram is, but it isn't a good causal loop diagram. Can somebody tell me why this diagram is not a good causal loop diagram? At least one reason? So notice there are three variables they put into this diagram. Temperatures rise, Arctic sea ice melts, and as reflective ice disappears, darker ocean water absorbs more heat. So there's a question about vague. It might be that this is a little too vague. Maybe they needed to get into a little bit more detail, but let's say that for their audience, this is the appropriate level of detail. More structurally, like, can we think of reasons like rules that were broken? If this was like, what points would you get marked off if you were to turn this into me as a causal loop diagram? And so what are some things that might be wrong with this as a causal loop diagram? Some things that we learned last time or you might be learning through the book. Anybody have some thoughts on that? Oh, sorry, Vensim is blocking. Oh, thank you for that. Apologize. There's a question here, or a point out that no plus or minuses. So right, that's one thing. So as a causal loop diagram, they have not indicated what the causal links are. They're counting on the reader to be able to spot, you know, whether the red link is a negative or the red link is a positive. So that's one thing. Are there more fundamental? There's no delays. That's another thing they said here. They said, you know, that reality, some of these delays probably matter. And so temperatures rise, maybe immediately the Arctic ice sea melts, and maybe immediately the reflective ice disappears, but maybe then it takes a while for the temperatures to rise again. So maybe we need a delay over here. That might be something. And there's no middle relationship loop, sure. Is there another more fundamental problem with how they've chosen the variables? The variables are not nouns. Yeah, that's what I'm looking for here. So they've packed too much action into the variables. So temperatures rise, Arctic sea ice melts. So from a causal connection, like it's easy to say, like, you know, hunger influences amount eaten. Amount eaten, that's a noun phrase. Hunger is a noun, it's a thing. These two things have an influence on them. The action is tied up into the link. When I start connecting verbs, it's hard for me to say how a verb affects another verb. How does temperatures rise affect Arctic sea ice melts? So in this particular case, you know, you could turn these into gerund forms. You could turn these verbs into nouns. You could say temperature rising affects Arctic sea ice melting. That's one way that you could deal with this particular issue. So I'm going to turn my pointer into a pin. So I'm going to say the verbs here: rise, melts, and then this is like definitely not a noun phrase at all. So one of the things we could do is turn those into like rising, melting, and then have to figure out something to do with this. But it's better to keep it as simple as possible. So does somebody have like a revision to this up top here that is much simpler than this, that would be much easier to interpret as kind of a noun that's involved in a causal loop? And so there's one suggestion: increased temperatures. And that's kind of moving along the lines of what I'm looking for here. But the trouble with the modifier increased is we're kind of packing directionality into the noun. So another option that's coming up here is temperature or global temperature. And so that's kind of, those sorts of things are what I'm kind of looking for here. You could be generic and say temperature, or you can maybe like, as been suggested here, maybe I do global temperature. That is how I make this more specific. And so global temperature here tells me exactly what I'm referring to here, and it's a noun. And so I could be more specific. Water temperature, sure. I could say global water temperature. You know, global temperature kind of sounds like it's the ambient air. Water temperature sounds like the temperature of the water. I need to figure out which one that I'm referring to here. For now, I'm going to leave it as global temperature, but all of these other things that are clear nouns that have, there's no verb baked into them. There's no, we're not saying the only, we want to say that we want to make something that could increase or could decrease. So the problem I have with temperatures rise is I can't tell how temperatures rise increases or decreases because it's already been baked into it. It's an action. You know, if I say increased temperatures, that's better because it's a noun, but increased temperatures, it's hard for me to understand how increased temperatures could decrease. Like decreased, increased temperatures ends up becoming sort of strange for me. And so it's just simpler for me to just say temperatures or come up with a more specific temperature. Likewise, down here, do we have some suggestions as to how to make Arctic sea ice melts better? Any thoughts there? I see a couple of suggestions. Any other suggestions? I think those are good ones. Yeah, so I think these things that are just basically, I mean, the simplest thing is just to get rid of the melts, right? It just turns into Arctic sea ice. And so if you wanted to be more specific, you could maybe make this amount of Arctic sea ice. So that makes it clear that we're saying that, you know, it's the quantity of Arctic sea ice that we're focusing on, or ice mass. That's a good one too, or thickness. Yeah, all these are great. And for this picture that the National Resource Council is painting, all of these suggestions that you've given me would be excellent here. Now, you might be focusing on one particular process where it's really important for you to isolate thickness, for example, or surface area, for example, in which case you really should be very specific and choose the right specific quantifier. For now, I'm just going to say amount and not be clear on what exactly we're measuring. All right, now over here, this is describing like a whole process. As reflective ice disappears, darker ocean water absorbs more heat. So what, you know, what we kind of want to do is like get rid of this completely and replace it with a noun or a noun phrase. And so what would be a good noun we might be able to put there? And we could use some fancy words that you might be able to heard within climate change. And so heat, that's one good one you might put here. So we could put like, H2O heat or something like that. And we might even think about taking the heat and maybe we would introduce it as another variable we put over here. I like this idea, heat absorption, ratio of dark water to reflective ice. These are all excellent. This is exactly what I'm looking for. All of these I would be happy with. I'm going to just put the word albedo here. And that is a simple one that, you know, just because it's nice one word here and it communicates a lot. But all of these other things I like too. And so the idea here is that as you get more sea ice, you get more albedo. And more albedo means more reflective ice. And as you get more reflective ice, then that's going to have an effect on these temperatures. So let's try to, if we're going with albedo, amount of sea ice, and global temperature, let's then now try to label these things. So as global temperature, what type of causal link is related to global temperature and amount of sea ice? Is that a positive or a negative link? I see negative. Let me see if there's any other votes, negative or positive. All right, I see some more negatives. All right, I'm willing to go with what you guys say. Let's do negative. That makes sense to me. And the reason it comes out negative is that if we get an increase in global temperatures, then relative to where temperatures were, then we would expect a decrease in the amount of sea ice. Now that might take some time. So maybe I put a delay here. So maybe I'll just write delay out here. So if I get an increase in global temperatures, then after the time it takes for the ice to melt, then I'm going to get less ice. And so I have a negative there. Now, in order for me to figure out this bottom link here, I have to forget what I did to the top link and just ask myself, all right, imagine if the amount of sea ice increased. Then how would that affect the albedo? So if I get more sea ice, then what happens to the reflectivity? Should I get a positive or a negative for this albedo? I'm seeing a lot of positives here. So I'm okay with that too. So let's put a positive here for albedo. And so this is saying that as I get more ice, I get more reflection. So I get more of that albedo. Now I need the last link here. So if I imagine what would happen if my albedo increased, if my reflection increased. Well, so what happens to global temperatures if you start reflecting more sunlight back out into space? Is this going to be a negative or a positive? All right, I see a negative. That's a good question. So I see a heats up, so positive. So so we have to think about that. Is it so if I get more reflection into space, then that means I am not absorbing as much heat into the planet. So these links are where we involve our domain knowledge, and maybe we have to consult a domain expert. We may not quite know exactly how reflection works, but I mean, so pretend like I'm your domain expert. As you reflect more light into space, then what's going to happen is that you're going to have less light absorbed into the Earth, and you're going to have less solar radiation being radiated off of the Earth as heat. And so, so that's why we want to make this a negative here, because the more reflection you get, the cooler the planet gets. You reflect light off and global temperatures rise or fall. Global temperatures fall. You get more reflection, temperatures fall. So, and that might also, I don't know if that has a delay or not, but so I put a delay over here, not sure if there should be a delay over here. And so if I look at that, I got two negatives. And so because I have two negatives, and I see a question here. The question is, but doesn't the original talk about the amount of heat absorbed by dark waters? So that's great. The original talks about darker ocean water. And so if we were to tell a narrative where this was darker ocean water, I might have instead of putting albedo here, I could have instead maybe put, instead of this albedo here, I could have put dark ocean water. And so if that were dark ocean water, then that would change the polarity of this link and would change the polarity of this link. That's the beauty of these weird dynamical systems, is that if I switch the variables, all the links end up switching in the same way. So right now, I was about to say this was a positive feedback loop. Now, if I change this to dark ocean water, it changes two loops. And so because it changes two loops, then I still get a positive feedback loop here. Oh, sorry, I was drawing on that. So what I was trying to say here is that this over here, we chose albedo, which is reflection. I could have instead chose dark ocean water here. If I chose dark ocean water here, then maybe this plus would become a minus and this minus would become a plus. So in that case, I would change the individual causal structure, but the overall loop would still be a positive feedback loop. So because we chose to model albedo here, then that's the reason for this negative. But you're right that we could have chosen to model the darker ocean water, which would change the story, which would change this link and this link, but the overall number of negative links would stay the same. Okay. So, and I apologize for drawing on the wrong screen there. Great, and so I am going to then call this a positive feedback loop. All right, so that is an example there of a positive feedback loop. Okay, so I'll work through this one a little bit faster here. And so here is an example that is from Jay Forrester, one of his earlier texts on system dynamics modeling, where they've got a diagram here of a hand controlling a spigot that's filling up a bucket of water. And there is a desired water level. Let's say the desired water level is here. And when the water is beneath that, that desired water level, then the eye notices that, and the eye ends up causing the hand to turn up the flow of water to raise that water level. As the water level gets closer to the desired water level, then the hand starts shutting the water off so that you end up getting a water level that is right at the desired water level. So this is what we're going to end up finding is a balancing feedback loop. And so we would need to come up with names for these things to try to develop, to see what's going on here, to prove to ourselves this is a balancing feedback loop. Now, if the simplest thing to do is to use the words that they've given us. And so here I see that water level has been given to us and flow of water has been given to us. There is a clear causal link between flow of water and water level, and possibly in return. So that sort of suggests to me that maybe I should put the flow of water as one of these and put the level as the other one of these. And so I just took the flow of the water level and put it here. And I put the flow of water and I put it here. And so now that I've chosen these things, then I have to say, well, does flow have an effect on water level? Well, sure, it does. When I increase the flow, I increase the water level. So that suggests to me that there's a plus there. Increasing the flow increases the water level. Now here's where it gets tricky. There's this desired water level up here. As my water level gets closer to the desired water level, as the water level increases, then the control mechanism that's implemented with this eye and this hand is going to cause the water level, the flow, to decrease. So there is a negative impact from level to flow. So as the level increases, you get closer to the desired, then the hand turns down the flow. So this is an example not only of a negative causal link, but is an example that all of this stuff, control policy information that's been given in the story of what's going on here, has been abstracted away so that I don't worry about exactly how it's being implemented in the real world. I'm just modeling the relationship between the flow of water and the water level. I could build a bigger causal link or causal diagram that involves the hand, that involves the eye, that involves the information and all of that. But it overall wouldn't give me a whole lot more kind of interesting features here. The most important features of the system is that there is a flow of water that increases the water level, and there's a water level that decreases the flow of water, so that overall I get a negative feedback loop or a balancing feedback loop. Is that clear? Are there questions about that? Does it see how we did that? Okay. And this pattern, we're going to see over and over again with balancing feedback loops. In the assignment that I'll give you today, then I ask you to come up with your own balancing feedback loop. And you have to think about things that kind of act this way. And they always will have some level that's being regulated, like a water level. They'll have something that affects that level, an action like the flow of water. And as the level gets closer to some desired set point, then the action will be backed off. So that's why there's a negative here. So I've thrown in a goal. And what this is saying here, that's like the target water level, like the goal. And as the goal increases, so like if in the middle of filling the bucket, someone tells you, actually, we don't need 1 gallon, we need 2 gallons. So that will cause you to move the goal upwards. And so if the flow of the water, this is flow up here, remember, was once at one point as it was tapering off, now that somebody's increased the desired level from 1 gallon to 2, the flow of water is going to jump up, and then it'll decrease again as the water level gets closer to it. So normally this goal is not participating in the feedback loop. This link is not counted when we come up with this as a balancing feedback loop, but it still participates in the overall system. So it's important for us to have there. So that this generic diagram here, this is our generic causal loop diagram, and this is our generic stock and flow diagram here that represents pretty much any simple negative feedback process. Now, I mentioned to you last time that if you couple 2 of these balancing loops around one level, you get escalation behavior. And if you're looking for a mental model of that, think to this bucket as if it has a leak. As you get more water in the bucket, then you're going to get a bigger leak coming out of the bottom of the bucket because there's more weight pushing on that. So you're going to get more pressure that's going to cause this leak to come out of here. But as the water level decreases more, you're going to get an increased flow of water. So overall, if you've got a policy that's constantly dumping water in the bucket, you're going to be managing to maintain this near some goal level. But it's going to require you to constantly be dumping water in, and there's constantly going to be water leaking out. And this is exactly like the temperature control example in your house. Because your house leaks heat out to the outside world, your heater has to keep turning on. And so even though the temperature of your house stays relatively constant, that constancy of temperature requires you to constantly be burning energy up, dumping waste energy out into the environment, and then compensating for that waste energy by reheating the house. So that's what's going on here. And this idea, when you have 2 coupled balancing feedback loops together, as we'll learn as we read the next reading for Unit C, that is referred to as escalation behavior. And you're going to see another example of escalation behavior as you read Chapter 2 for this unit in a highway example that they talk about in the book. All right, any questions about that? All right. So I'm going to leave as kind of an exercise for you this example that I'll let you kind of do on your own time here. But this is a population example where someone has attempted to create a causal loop diagram, and I want you to think about how to properly fill in this diagram, but also think about what improvements could be made. One that I'm going to point out here is that they put births on here twice. And it might have made sense to them to sort of say that, there are 2 ways that births are involved. Births have a particular relationship to population here, but births also are connected via food supply. And maybe they thought it would be too ugly to draw the food supply link going up this way, and then this births link coming back down to population, though there's already this link down to population. And so they decided to have a double births here. But you should never duplicate variables like this if they're all in close proximity together. There's no reason to just not draw this second link. So this is kind of an ugly thing to do, is to put births as a second link there. But if you end up doing this diagram, this is kind of spoiler alert, then what you should end up finding is that you're going to have a positive feedback loop representing the birth process, and then you're going to have 2 negative feedback loops. And one of them will be related to the depletion of food, and one of them is going to be related to deaths in general, if I remember this correctly. But overall, what you're gonna hopefully end up seeing here is that S-shaped growth archetype, where you've got a reinforcing loop, a positive feedback loop that grows the population. But once the population gets sufficiently large, then that large population is going to end up running out of food, and you're going to get an increased amount of deaths. So that's so hopefully you'll end up seeing that. So I think what this will actually end up showing is not only will you get more deaths, but you'll get fewer births, because what you'll end up seeing here is that with less food, you'll not only produce more deaths, but you'll produce less babies. And so with the decline in food, then there's two ways that you get a decline in populations. So initially, when there's plenty of food and hardly any population, it's all growth. But once you get some population there, you start getting death. And once you get a large population, you get less food, which will produce even more death and even fewer births. And that will end up being what shows up over here. So this is not escalation behavior. This is we're just going to call it the S-shaped growth dynamic mode. So these are two dynamic modes. When you have a balancing loop that comes after a reinforcing loop. So when you have positive feedback next to negative feedback, then that is when you get S-shaped growth. Escalation behavior is when you have two balancing loops together, and they're both trying to regulate the same level. So they're both trying to regulate this level, but the leaking one is trying to bring the level down, and the filling one is trying to bring the level up. And the tension between them causes the level to be flat, while the other two just keep running. So escalation behavior produces one type of dynamic mode, but then this reinforcing next to a balancing produces another mode, where you get a rev up in growth, and then it levels off, and then eventually the system settles down at some terminal growth value or terminal population level. Okay. And then you can imagine adding other feedbacks. All right, so any questions? All right. So all that's left here is an assignment that I want to make sure that you guys are square on here. But the next lecture, lecture B3, we're going to be going over Moorcroft's version of this material. So chapter 2 in Moorcroft. So there's a perusal assignment out there. A lot of you have started reading and adding comments to. There's an at-home reading exercise. It'll help you read through it. And then before chapters 2, so before next lecture, make sure to do the timed reading assessment. You got 20 minutes to do that, to make sure that you kind of have got an assessment of that. And in the perusal assignment, I've kind of highlighted things, the sections that I think are kind of most important, especially coming up to this reading assessment. So take a look at that. So for today, you have got an assignment, which is you'll end up turning in on Canvas. The first part of it is going to give you a causal loop diagram that tells the story of these two technologies. So once upon a time, you would go out to a video store and you would rent these things called, these video tapes. And there were two formats that were out there. One of them was called Betamax, and the other one was called VHS. And I'm only using this archaic example because it is a nice example that I could lift from a book. Nowadays, I could probably rewrite this example with maybe iPhone and Android. What I like about this example is that one of them clearly dominated. There wasn't a coexistence. So we've got these two formats out there that initially both formats were in the market, and you could go to a video store and buy either type of these. So there ended up being this causal link here where there were these VCRs that were out there that either were of the VHS variety or the beta variety. And so there ended up being two loops here. So as you had more VCR that were sold that were VHS type, then that ended up leading to more VHS VCRs in use, which led to more customers at the video stores asking for the tapes, which ended up leading to more tapes in the stores, which ended up leading to a greater market share for VHS and likewise a lesser market share for Betamax. But you could also walk around the other loop and you could say, as you get more beta VCRs, you get more beta tapes in the stores, you get more customers asking for those tapes, you get the more beta tapes in the stores, which would then decrease the market share. So what you should be able to do is label all of the links in this kidney-shaped diagram, I guess urinary tract sort of shaped diagram, and be able to then also label the loops. And spoiler alert, what you should end up finding is that this is a positive feedback and this over here is a positive feedback. So this is another one of these dynamic modes of behavior that we're going to start talking about. So this is your first kind of exposure to that. So you have to label all of these, and by label them, I mean, you're going to have to draw this in Vensim. So you want to draw this in Vensim, and then as you're drawing, not only what's already on here, label every link and then label every loop. And then that's basically all you do for the first question there, and that's outlined on the Canvas assignment as well. So are there any questions about the setup of this? I know these are technologies we don't see a lot nowadays. Yeah, and so normally when I do this in class, I say go ahead and do one partner, and I would normally hang around for a few minutes. Unfortunately, I have a meeting at 4:15 that came up as kind of an emergency meeting today, so I won't be able to hang around that much here. But of course, you can work on this with people at home. Just make sure that you turn in an individual assignment. So I want you both to be drawing it. So when Eric is grading these, I don't want him to see the exact same diagram. Your diagram should have variables in slightly different places, maybe be shaped slightly differently, so that it's clear that you both have done an independent diagram. All right, so let's do our last attendance exercise here. And again, I will someday figure out my pacing so that we will have more time at the end of these lectures so that we can go into breakout rooms, and so you can end up working on these things together. But I really appreciate all of your interaction during the lectures. So the question I have for you here is, what is the system archetype name associated with two balancing feedback loops that are fighting to control one level? So we've talked about there are a couple of different dynamic archetypes that we're starting to introduce. And so the first one that I kind of introduced here was two balancing loops together. This is like the bucket that was leaking as it's being filled. So there were two balancing loops there. One balancing loop was trying to empty the bucket. The other balancing loop was trying to fill the bucket. Ultimately, the two loops balanced out so that there was the bucket stayed at one level, but that required constantly filling and constantly leaking. So what is that archetype called? It's just a word. I used a single word for it. And so otherwise, I can hang around. Again, unfortunately, I don't think I can leave my room open because I have to join another Zoom meeting shortly after this meeting, but you are definitely welcome to work together on this assignment. And that's all I've got for you today. So if you have any questions about Vensim, please feel free. I can hang around for a couple minutes. Unfortunately, I have to take off after that. All right. Thanks all.